Right then, some more properties, right? So in the previous session, we learned an important property, which is angle subtended by a chord at the center is twice the angle that it subtends on the circumference. Now, and even before I move to the next property, let me establish a corollary of the previous property. That means angle at the center is twice the angle on the circumference, an important implication of that property, very commonly used, right? The property or the corollary that I am going to establish is the following first. The angle subtended at the center, twice the angle on the circumference, angles in a semicircle is a right angle. That's a very direct implication of the previous property. That means if this is a circle, then the semicircle will be obtained through a diameter. This is a diameter, which is also a chord of the circle. A diameter is also a chord of the circle, right? And if P be any point on the semicircle, then I want to establish that this angle, which is angle in a semicircle, will be a right angle. Now, again, it doesn't take too much to establish this. A direct consequence of the property, that is the angle at the center is twice the angle on the circumference, will lead to the fact that an angle in a semicircle is a right angle. Okay, look at this chord AB, which is also the diameter. This chord AB is also the diameter. And the angle that it subtends at the center is this angle. This is 180 degrees. The chord AB subtends 180 degrees at the center. And therefore, the angle at the center, this, is twice the angle on the circumference by this chord AB. Also happens to be the diameter of the circle. So this angle 180 degrees must be twice the angle at P. That means the angle at P must be half of it. That means 90 degrees. Therefore, angle in a semicircle is a right angle, a direct outcome of the previous property, that is the angle at the center is twice the angle on the circumference. So angle in a semicircle, right angle, right? So remember this, keep a tab on it, make sure you get it right. All right, now let's move to the next property, which is as follows. The next property that we are seeking to take care of is the following. If I take any 2 points on a circle, say point A and point B, any 2 points A and B on a circle, then these 2 points divide the circle into 2 parts. This one, for example, which is the smaller part, is called a minor segment. This part is called a minor segment. This one, which is bigger, is called a major segment. So 2 points on a circle, 2 points on a circle will divide the circle into 2 segments. These 2 segments could be unequal, like is the case here, and when they are unequal, the smaller segment would be referred to as the minor segment, the bigger segment would be referred to as the major segment. And the 2 segments could also be equal in length. When does that happen? If A and B divide the circle into 2 equal parts, that happens when AB is the diameter. When AB is the diameter, then this segment and this segment, they are equal and they are 2 semicircles. They are 2 semicircles. Then we don't have a major and a minor segment. In any case, one way or the other, 2 points will divide the circle into 2 segments. They would either be unequal, as is the case, or if AB is the diameter, they would be equal. Now, let me look at this segment, for example, this minor segment, for example. If I select a point P, anywhere on the circumference of the other segment, so AB then subtends the segment AB, say this segment AB subtends an angle APB at the point P. subtends an angle APB at the point P, right? We want to establish that the angle that this subtends at P, the segment AB subtends at P, is the same as the angle that it subtends at Q, where Q and P belong to the same segment. If Q and P are points in the same segment, if P and Q, see in this case, P and Q are both points in the same segment, that means the same major segment in this case. If P and Q are points in the same segment, then this segment AB subtends an angle at P and subtends an angle at Q. We want to establish that the angle subtended by the segment AB at P and Q must be the same if P and Q belong to the same segment. If 2 points P and Q belong to the same segment, then the angle subtended at P and Q by some other segment must be the same. Right? That's a property. That means angles in the same segment must be equal. Subtended by an arc. In this case, you can call this the arc. Angle subtended by an arc at points in the same segment must be equal. Right? Now, not difficult to establish, not difficult to establish. Let me look at the center O of the circle. Let me look at the center O of the circle. Then this arc subtends an angle AOB, which is alpha. Angle AOB I refer to as alpha at the center. The angle subtended by this arc at the center is alpha. The angle subtended by this arc at P is this angle. And a property that we learnt in the previous session was the angle subtended by an arc. Sometimes, just to clarify things, if someone says, this is a chord AB and this is a point P, and he says this is the angle subtended by the chord AB at P. If someone says this is the angle subtended by the chord AB at P, then one can also say that this is the angle subtended by this arc AB at the point P. That means the same. The angle subtended by this chord AB at P or angle subtended by this arc AB at P is actually the same. It means the same. So it's just a difference in terminology, but it means the same. So I'm not drawing the chord AB here. Therefore, I simply say the angle subtended by the arc AB at P. This is the arc AB. This is the arc AB, and the angle subtended at P is this. And the same kind of a property, because irrespective of the chord or the arc, the angle subtended by the chord at P or the angle subtended by the arc at P is going to be the same. So angle subtended at the center by an arc or by a chord is twice the angle subtended on the circumference. That means this angle must be twice this angle. That means angle alpha must be twice angle APB, leading to angle APB equal to alpha by 2. The angle at the center twice the angle on the circumference causes this angle to be alpha by 2. Causes this angle to be alpha by 2. Exactly the same way, the angle subtended at the center O will be twice the angle subtended at Q. That means angle alpha will also be twice angle AQB. That means angle AOB, that is alpha, will be twice angle AQB, which means angle AQB must be alpha by 2. This must be alpha by 2. That means these are 2 points in the same segment, referred to this segment AB, referred to this arc AB. P and Q are points in the same segment, and the angle subtended by an arc or by a chord at points P and Q that lie in the same segment must necessarily be equal. So leads us to an extremely important property, again commonly used. Wonder why I'm calling all these properties extremely important, because they are equally important, indispensable, so commonly used, fun-filled, and we are going to have a, a, a great time once we connect all these properties, put them in application in a single problem. There is going to be simple ecstasy, absolutely ecstatic is how you would feel. So angles subtended in the same segment must necessarily be equal, a property that we've come to terms with. So then you are becoming richer in your vocabulary related to circles. Very shortly, I'll add some more stuff so that you can feel stronger and armed. Thank you very much. Again, just in a little while, you'll see me. Bye-bye.